Right. Thanks, Sarah and Hannah, for having me on this HashiTalks event, and thank you all for joining also for the final talk today. So Terraform Your Pets, a Terraform provider for operating system resources is the title of my talk. And before we dive into that talk, I'm Dominic. As our hosts have already introduced me, I'm independent cloud solutions architect and engineers. And in the usual projects I'm doing, I enable software development and infrastructure engineering teams to efficiently build and operate cloud infrastructure to run their applications and services. And in almost all of these projects, I've applied, introduced, or trained engineers on using Terraform as the primary tool for managing cloud infrastructure. And with this background, and whenever there was a use case, I've also contributed in the past to major Terraform providers, for example, to AWS, GCP, Azure, or to the Helm provider. And therefore, my background not only covers Terraform in practice, but also includes Terraform provider development. In a nutshell, what is this talk about? So I want to present you a side project, or I would also call it an experiment I've been working on. I would like to present you a community Terraform provider, which allows you to manage Linux operating system resources on remote servers. And the operating system level resources I'm talking about are like really basic, essential resources like files, directories, users, groups, packages, and services. So resources which you would maybe also configure using Ansible. And the provider I'm presenting manages these resources via SSH and without the need to install an agent on the remote server. So it's really similar to Ansible. The provider is already published since the beginning of September. You can find it in the Terraform Registry. And the source code is also published on GitHub. So let's get over the agenda of this talk. First, I want to argue, or I want to give you some background on the motivation for me to create this provider, and basically argue why you would need this provider. I would also present you generic use cases and also specific examples for which you can use the provider. Third, we'll briefly look into the concept, and I'll highlight essential features so that the stage is ready for the best part in the live presentation, the demo. So in the demo, we will see, takes about 15 minutes to see the provider in action. And if you're convinced after the demo, I will tell you what you need to get started, especially point you to documentation and examples. And in the final part, I will highlight some possible future improvements, or some people call it today's limitations, and also what could be interesting integrations with this provider. All right, first of all, I'm a proponent of cloud-native services, so which cover serverless and immutable infrastructure, and this is my daily business. And I advise customers to make use of these cloud-native services, for example, to benefit from scaling or from not being in charge of managing servers. And we know Terraform is a great tool for managing cloud-native infrastructure and immutable infrastructure across different cloud providers with a nice, consistent workflow. However, every once in a while, I encountered scenarios which involved non-cloud native infrastructure, so small-scale, mutable infrastructure. And these scenarios were legit, and it was reasonable. And often that means individual or like a pair of Linux boxes. And in these scenarios, I would have wanted a consistent configuration management workflow, but in these scenarios, it would be too hard or impossible to realize the configuration via an immutable infrastructure pattern. Also, there are a lot of IaaS providers which offer cheap or cheaper compute than, for instance, AWS EC2. Yeah, think of Linode, think of DigitalOcean, think of Hetzner in Germany. And whenever these use cases or scenarios, I can ask myself, can these scenarios be covered reasonably with Terraform? And if so, what is missing to adopt Terraform for these use cases? So oftentimes in practice, you find like combination of Terraform and Ansible. So Terraform for the infrastructure and then Ansible for the operating system resources. And then you have a break in tool responsibility. Also, there are approaches like Cloud Init. However, Cloud Init is not suitable for bare metal machines or for system on a chip computers like Raspberry Pis. So those were basically the thoughts in which I had when I came with the idea to implement this as a Terraform provider, which manages the most essential Linux system resources necessary to do something to make an application running, basically. How hard can it be? Use cases. In general, the use cases, or in general with the provider, you can configure files, directories, users, groups, packages, services on individual bare metal or virtual servers, on premises, or in the cloud. So that's it. That's a summary of the generic use cases, and all these scenarios combine like small static scale infrastructure. Yeah, in their use cases where you don't have like large scale infrastructures, and also it's suitable for mutable infrastructure. Specific examples. You can use the provider to run a web server on a single virtual or bare metal server. And in the demo, we are going to see how that looks like. You can also think of bootstrapping a static node Kubernetes cluster, for instance, K3s with 3 nodes, and then continue using the Kubernetes API. You can, as I pointed out earlier, you can configure your lab or home servers. Yeah, there are lots. There's a huge community for like these system on a chip computers like the Raspberry Pi. Basically, you can replace the step-by-step command instructions you find in most blog posts on the internet. You can also replace the Terraform built-in SSH provisioner. So when you use this provisioner, for example, for the deployment of files, the provider, which I present, gives you a much richer experience, especially when you change these files. All right, let's summarize the concept and features. I've already told you what you can manage with the provider. The provider itself connects to the remote server to be configured via SSH. It connects directly or via Bastion host. In lots of scenarios, you find Bastion host be deployed. So this is also supported. The provider authenticates via SSH private key, SSH agent certificates, or if you dare, also with a password. Both SSH connection and authentication is very stable and should have no limitations for your use case. So this is more than a proof of concept. You can do privilege escalation with sudo, so connect with a non-privileged user and then escalate to execute the resource changes. There's no agent required in the remote system. Think of Ansible. The provider aims to seamlessly integrate with other Terraform providers, for instance, by IaaS cloud providers, DigitalOcean, Hetzner, for example, and the provider supports Debian, Alpine, and Fedora Linux, and this support is confirmed via separate acceptance test suites. All right, I want to show you some snippets, and I can imagine that you immediately can think of what the provider does by looking at these snippets. So this is a provider configuration, host and port for the SSH connection, and the provider authenticates then with the private key loaded from a file. This is how the provider configuration looks like when you want to authenticate via an SSH agent. Next, this is how a resource, or the file resource, looks like, which ensures that in the hello world txt, there's like there will be the static content hello world, and the resource makes sure that the user and group, or the file is owned by user and group John Doe, and sets the permission to 600. Another example is the packages resource, and the packages resources are always specific to the package manager implementation. So this is an example for the app package manager, which works on Debian or available on Debian. And this example ensures that Nginx and Open SSL packages are installed. All right. So before we dive into demo, I would like to summarize what we will do. So the goal is to run an Nginx web server on a virtual machine in the Hetzner cloud. I chose Hetzner as a local hosting provider, because this is HashiTalks in the DACH region, and Hetzner is it's quite popular, and I guess most IT people will know in Germany. Side note: the VM which we will provision is less than 5 euros per month, so good for like experiments, small applications, etc. So we launch a Debian virtual machine, we install Nginx, we configure a virtual host for Nginx, we configure a static web page, and we finally start the Nginx service, or ensure that it started. And then we would like to see the website up and running. All right. Switch over to the demo. So I've prepared a root Terraform module web server demo, which includes 3 submodules. And I really give you a quick summary. We first generate an SSH key, private key, with the first submodule. In the second submodule, we provision a virtual machine in the Hetzner cloud. We provide it with the public key we've generated. And as the outcome, we would expect the virtual machine to be running, and the module gives us the public IP address. And now comes the interesting part, which is the integration with the system provider. So we will use the public IP address, which we get from the earlier hcloud VM module as a host to connect, and we use the private key which we generated earlier to authenticate. And then we basically configured the system provider and feed it into a submodule called Debian Web Server. And this is an interesting module we can look into further now. So here you see how the resources of the provider work together. We install Nginx. I've already shown you this resource. And here we create a nested folder structure, which will serve as the document root for our HTML document. And you already see that the provider supports the implicit resource dependencies, which is Terraform native feature. In this folder, we create an index HTML from like static content, and we want to greet the HashiTalks DACH community. We also use the system file resource to create the Nginx virtual host configuration. I'm not going over to the details here. it's just serving the index HTML is the goal from the document root. We need to enable the virtual host configuration, and in Nginx, this means we create a symbolic link. And this is also one feature I haven't mentioned before of the provider. And last, we want to ensure that the Nginx service is enabled and started. And this is achieved by the service system D resource. And yeah, we need to define some explicit dependencies here because we need to ensure that the package is installed before we can start it. All right, let's give it a shot and initialize the project. So we are all doing it. So VM provision and configuration of the machine in one Terraform run. Yeah, you can also separate this if you want, but it's also supported in one shot. Terraform apply. So we verify that we have 11 resources here, which is like a mix of these hcloud server resources and our system resources. I'm not going to review this in detail. And provisioning should take about 60 seconds. And I can use the time to explain some details on the built-in resilience in the SSH provider. So obviously the VM, the SSH server on the VM needs some time to come up even after provisioning. And the provider or the system provider will in a smart way wait for the SSH connection to be ready when applying the individual resources. So this is why still creating takes a bit, but this is only if you provision infrastructure in the same Terraform run. Yeah. So even less than 60 seconds. Shout out to the colleagues from Hetzner. All right. I think we should now be able to verify that the website is reachable. And if you can't do it during this live presentation, this is due to a firewall rule I've applied. So you can't interfere with my demo. So demo with curl shows our index HTML. That's a greeting to you. All right. Then what makes Terraform really powerful are changes to infrastructure. And now let's say we want to add this. We want to change this page by adding something, and we would do this by revisiting the index HTML resource and just give an update. Update first part of the demo was successful. We save and apply again. And now it's much faster. I would claim it's also much faster than Ansible. And due to the nice Terraform plan layout, we immediately see the change and can confirm it. And yeah, run curl again to review that we have an update on our website. All right. Now you can claim, well, that is easy. You change the static page, but what happens if you change or if you want to change the virtual host configuration? Wouldn't this require a reload of the Nginx service? True, yes. And I will show you how that works. So remember, we configured the virtual host also using the system file resource. And now let's say we want to add a header. Header doesn't matter. We just want to have this header now in the response. We save, and now the provider would change the contents of the file, but a reload of Nginx is necessary to pick up the changes. And this is a way, and this is ensured by the reload on attribute in the systemd service resource. Yeah, so we basically tell the systemd resource here to trigger a reload whenever there's a change to the content of the virtual host configuration file. And let's apply again. And we see the two resources now, the adding of the header, and we see that we have this reload attribute change, which will trigger a reload, and we apply. And now let's hit curl again, this time with verbose, so that we can see the header in the HTTP response. All right, last part I want to show is how you can upload a file. And you can upload a file directly from a local path. So local means where the Terraform provider or the Terraform client runs, or you can specify an HTTPS URL. And the way it works is the remote server, the connection to this URL to download is not established from the remote server directly. The provider connects to this URL and streams the contents into the file on the remote server via the SSH connection. So this gives the benefit that the remote server, that in the remote environment where the remote server is, you don't need any additional firewall rules, whatever, to allow this connections to this host. The only requirement is the SSH connection between the provider and the remote server. So I need to save, obviously. And we basically expect that the contents of this file from this URL can then be found after an apply in the root HTML path, so next to the index HTML. Let's apply again. And we see a new resource here. And if you check the source, so the provider will check for the e-tag returned by the remote web server here. And whenever there's a change to the e-tag, this indicates updated content on this URL. And in this, using this indicator, the system file would know when to update the remote file, even when the URL changes. Let's do it. Great. We have created the file. So let's check if we can also download it. So I've prepared a second curl command in which we, instead of the index HTML, retrieve this checksum file. There it is. This was the demo of the provider. We need to finally clean up. Also, destroy works as expected. I don't know how long the destruction of the compute virtual machine works, but yeah, seems pretty fast. Great. All right. How to get started. So as I mentioned earlier, the provider is already available via the Terraform Registry. This is the snippet you would add to your Terraform root module to use it, or to other Terraform modules. I recommend you to check out the documentation, especially the documentation on the resources contain more usage examples than I have shown in the demo. Yeah. So for instance, think of a combination of the file and service resource. So you can create a service unit, systemd service unit, and then start it. So this is the way the usage of this provider is intended. So you can cover lots of use cases with a small set of essential resources. Yeah. You can also configure like a Docker host and then host the rest of your service in Docker or in Docker containers. Also, SSH authentication and connection sections contain also additional examples, especially how to connect using a Bastion host. All right, now we have this provider. The provider, I would argue, integrates seamlessly within the Terraform ecosystem. So I've shown you in the demo that it integrates well with other Terraform providers. I would also claim, but have not tested it, the integration or running this on Terraform Cloud or Terraform Enterprise. I would also expect this to integrate with Terraform CDK. We've had Terraform CDK introduction talks today, and I would expect the provider to work also in these scenarios. Future improvements. So I can think of supporting additional package managers. Currently, apt and APK is supported. Why not DNF and YAM? We can think of a custom command resource to execute arbitrary commands. However, I would say this needs to be carefully designed, and here feedback from the community is also appreciated. What also can be done is additional test coverage for additional Linux distributions, like for instance for Ubuntu or Red Hat Enterprise Linux. You may already try out the provider for Ubuntu, but there's no test suite covering this, although we have a Debian test suite. The last 2 points are ideas for cloud native integrations to make this provider work better with like virtual machines in like AWS, Azure, or GCP. So first is like you can think of a cloud native SSH connectivity. So AWS and Azure, they have kind of Bastion services which allow you to establish an SSH tunnel to EC2 instances or Azure virtual machines without the need to expose the SSH protocol publicly. And the other advantage is that for authentication, you can use then the cloud native AWS or Azure IAM instead of SSH keys. So AWS Systems Manager integration could be configured with just specifying a single name of the EC2 instance to configure and no IPs, no SSH keys, etc. The second or the last feature I would highlight here is like support for cloud native SSH key signing. So instead of providing an SSH key as a file or via the agent, the provider could just reference an asymmetric key in one of these cloud native KMS services. And again, this makes the authentication part a bit easier. So shout out to product managers at AWS or Azure for these services. This might be interesting. All right, that's it. Thank you for joining. I encourage you to try the provider for use cases you see. Report issues via GitHub. Also, feel free to contribute. So check out the project from GitHub. Pull requests are more welcome than issues. I will be available in chat after this session for questions. Hope to see you there. Thank you.